Welcome to the third installment of Cillerside Chats. I'm Bill Morris. Today we're going to be covering what I refer to as the heart of the chilling operation, the Rechiller. Obviously, the primary purpose of your chillers is to bring the temperature of the birds down quickly, or more accurately, to remove the heat from the thousands of 100-degree birds that are passing through the system. The chiller actually transfers the heat from the birds into the water surrounding them, and then the rechiller's role is to quickly remove the heat from that water and return it to the chiller. Now let me start with two key characteristics you should look for in a solid rechiller system. Number one, by a long shot, is reliability. If your rechiller goes down for any reason, you will have hot birds, period. The second thing you should look for is effectiveness. Does the rechiller return all of the water at consistent temperature? If not, you will have variation in bird temperature exiting the chiller. Okay, so let's dive into reliability. The biggest stress on your rechiller occurs at the end of the shift during cleaning. Every single day, your rechiller is ideally operating at around 32 degrees water, and then 130 degree water is flushed through, causing rapid expansion of the tubes. Doing this thousands of times puts tremendous stress on the joints, where the tube sheet attaches to the shell and the tubes. This can result in ammonia leaks and shorten life of the unit. This was a common occurrence throughout the 1990s. In fact, our own rechillers suffered from this problem then. And as rechillers became longer to meet increased production demands, this issue only got worse. Determined to address this issue, we totally redesigned our rechillers from the ground up in the early 2000s. What emerged from this process was a much more effective rechiller and one with greatly enhanced reliability. We continue to manufacture and install this rechiller design today with great results and reliability. Most of our competitors are still manufacturing rechillers based on the design and engineering of 30 years ago and are still suffering the same failures. So what's different about our design? Well, let's start with a view from 20,000 feet. The odds of failure in any piece of equipment are directly proportionate to the number of components and moving parts. More is not better. 1980s designs used pumps to push ammonia through uncleanable spray nozzles permanently mounted inside the rechiller to cool the tubes carrying the warm water. Pumps fail regularly. Cavitation occurs, resulting in permanent performance reductions. The pumps themselves require special cooling, yet more energy required. These pumps can also introduce particulates into the critical ammonia supply lines. There's no getting around these issues, which is why you always see a permanently installed backup pump for redundancy on these old designs. And if one can fail, and it will, so can the second, resulting in significant downtime. Hundreds of thousands of dollars are at stake because of a $9,000 pump. Not good. Our rechiller does not use pumps at all. Instead, a small amount of high-pressure gas is siphoned from the compressor, driving ammonia through externally mounted eductors into the top of the rechiller. Then gravity takes over and evenly distributes the ammonia over all of the tubes. And by the way, our rechillers have approximately 15% more heat transfer area as documented in the National Board Data Report for the same rated capacity. Eliminating pumps altogether improves reliability by reducing the risk of failure while also improving effectiveness. Let's turn to how the ammonia is distributed within the rechiller. Other rechillers on the market use a series of internally mounted spray nozzles to attempt to evenly cover hundreds of feet of tubes stacked on top of each other. A very difficult, if not impossible task. Our unique gravity feed system does not use spray nozzles and dramatically enhances the wetted surface of each tube, completely covering each tube with ammonia. The end result? Consistency, a word you will often hear from us. Now, with two pumps completely eliminated, we still have the expansion and contraction of the tubes to contend with. All rechillers are subject to severe stress when hot water is introduced to the tubes, and they will expand and contract. Highways and bridges experience this same phenomena, which is why expansion joints are built into their design and construction. Likewise, our rechiller includes an STS feature, which allows for regular tube expansion and contraction without damaging the structural integrity of the rechiller. Without STS, even our design would be vulnerable to tube cracking, and of course, the 1980s design sold by other equipment manufacturers risks significant failure for the same reason. Certainly, everybody wishes their equipment worked perfectly 100% of the time, but that's not the case, and service is occasionally required. So consider this: if you're using a 1980s design rechiller, still being sold today by the way, which uses spray nozzles, what happens if one of those nozzles clogs? First, the only indication you will have is a drop in rechiller effectiveness, not chilling the water. But there is no checking on the spray nozzles or cleaning them, as they are totally inaccessible. You're out of luck. So why would they clog? Could be a variety of reasons. Some central ammonia systems are better than others, but every system has trash in it. And water in the ammonia system, when mixed with oil, results in sludge. Pumps can also throw off particulates. During a recent forensic examination of a competitive rechiller with the 1980s design, several nozzles were found partially or entirely plugged. It happens, and there's no fixing it once it is in service. As discussed earlier, our rechillers use eductors and gravity to distribute the ammonia rather than pumps. And importantly, our eductors are on the outside of the rechiller, making them easily accessible and cleanable with common tools. A word on effectiveness. Control is critical for any machinery, and particularly for your rechiller. The Morris rechiller utilizes a continuously variable control valve which reacts more accurately to temperature changes in the rechiller and precisely adjusts the flow of ammonia to achieve consistent temperatures immediately. I get that that's a lot of information on a somewhat difficult to explain piece of equipment. But in a nutshell, the Morris rechiller is a more effective and reliable rechiller. It is more effective and efficient at chilling all of the water in all of the tubes with tighter control. It is more reliable due to the reduction in moving parts, as well as the STS system, which accommodates the regular contraction and expansion of the rechiller tubes. The 1980s design, still sold by competitors, continues to suffer from the same shortcomings that led us to redesign the Morris rechiller nearly 20 years ago. And don't think our design improvements stopped with the rechiller. We continue to improve on all of our designs. In fact, the rechiller alone has received 35 enhancements in the last 15 years. One cool idea after another is not just our slogan, it really is our passion. Stop by our North Carolina campus and let us show you what we're working on for tomorrow.